GBADs. Welcome everybody to this GBADs DECIDE webinar. We try to do this a couple of times a year, and this time it's about data requirements and opportunities in global animal health research and decision makers. So with other words, how can we reuse animal health data for decision making to improve animal health? And we have three presenters today. And the first presenter is Emma Jane Murray. She does her PhD at the University College Dublin at the School of Veterinary Medicine. And she is researching the burden of cattle diseases in Ireland. And her project contributes to the larger global burden of animal diseases program. Her background is in public health, veterinary epidemiology, and governance animal sciences. And just for you to know, questions will be after the three presentations. You can already put questions in the chat. So when people are finished talking, they may start answering your questions already in the chat. We will have a discussion round when the three presentations, and all the presentations should be about 12 minutes each. So let's start with Emma Jane, and then I'll introduce the other people when they start talking.
So hello everyone, and thank you for the introductions. I'm here to talk about the opportunities and lessons learned from the GBADs Ireland case study. I'll be talking through some bits of the methodology, but I won't be going into too much detail because Camille and Kassy will be discussing their work at European and global level, and which will be quite useful for those in animal health research, but also decision makers that want to see what's going on in the realm in terms of metadata and what we can do with it. So, just make sure I can actually move my screen. So moving on to the agenda, I'll be kicking things off at country level and specifically about our research in Ireland using national databases and the opportunities in using cattle registration and tracing systems. Camille will be discussing integrating animal production data and the gaps and challenges that scientists face at European level. And Kassy will be talking through how we can use metadata-driven graph databases and streamlining the discovery of data. So I want to quickly kind of give an overview of the Irish case study. So the main aim of the study is to estimate the burden of cattle diseases, so it's no small feat. So we have four main goals, starting with the majority of what researchers begin with, trying to figure out what data are needed, who the data owners are, and where to find it. For instance, we are doing data mapping of cattle health data ecosystem in Ireland, looking at the main data providers, private and semi-private. Once this is complete, the data mapping results will be useful for identifying data gaps, potential data sources for future studies, and also contribute to the Open Data Initiative, highlighting diseases that aren't captured, gaps in data for surveillance purposes, and also who are the main holders of data, and hopefully be a directory for researchers specifically in Ireland, but might be useful at a global scale as well, whoever's interested in Irish data. Kassy will actually be talking to us about the public data and further explaining, this at the global level. And then kind of moving on to the livestock biomass and stock value. So biomass is, in other words, live weight, and looking at the distribution across nationally at sector level and herd level from 2011 to 2021. And just in case somebody doesn't know in the audience, biomass pretty much is a denominator, important production metrics, including productivity, environmental impact, disease management, and antimicrobial usage. Accurate estimates allow better cross-sectoral and international comparisons and can inform policy decision-making. Similarly, livestock values are needed to monitor economic efficiency and productivity, and it can also help us understand the costs associated with animal health policy decisions. So moving on to the estimation of animal health losses, which is based on the animal health loss envelope by GBADs, and I actually have a QR code for their technical guide, which goes into a little bit more detail in the final slide in case anybody's interested. But the aim of this particular aspect of the study is to use movement data and economic marker events to measure animal health loss and efficiency on farm. But I'll talk further about that in the later slides. And then the final goal is attributing that to major diseases in the Irish cattle sector. So going straight into giving an overview of the methodology of the livestock biomass and stock value. We have 3 data sources from the Department of Agriculture. Data from data source 1 is from the bovine TB positive reactor slaughter data, which is from the bovine TB eradication program, and key variables being age, sex, breed type, live weight and price. The second one being the market data, which we can use as a way to validate the value predictions that we got from the first data set. And the third data set is from the actual main animal identification and movement database, which we can run the models through that herd composition data, and hopefully, or not hopefully, we have done it, and give a figure for each animal in the country on a monthly basis, so where they are on a monthly basis, and give a live weight and value figure from 2011 to 2021. And also the herds themselves were classified based on Brock et al.'s herd classification tree model, which I have a reference to in the final slide for those that want to learn more about it. And I won't go into too much detail on the methodology side, as I'm conscious of time. So I'm just going to cut straight to it and show the data. And these are some of the data, some of the results that you can get from big data from things like the disease eradication programs or national cattle registration systems. So, for instance, our estimates on livestock biomass and its associated stock value, as you can see on the top left there. You can look at temporal changes over the years, between years, and also within years. You can look at that at sector level, herd level, and animal level as well. So it's just, to show the types of opportunity that you can get from using such systems, data sources and stuff. And also it's worth mentioning as well that the values that we have got here are adjusted for inflation. But if anybody's interested in knowing the nominal values, I'm happy to discuss that with them as well. So this study is actually in review at the moment. So hopefully in a few months, our results will be published for anybody interested in reading them. And going straight into the animal health losses. Regarding that, something that you probably noticed, it's pretty much using the same animal identification movement database. It is quite useful, just using different parts of that database with specific interest in the movement. On the left there in the middle is the calving data, and combining those to get the number of days an animal spends on farm in a specific year. And of those days that they spend on farm, which are productive and which are unproductive, based on thresholds that we have put in place for parameters such as fertility, so calving intervals, growth, so related to growth to slaughter and growth to first calving, and death as well. So I hope that you get to see the key variables that we use. We don't use an awful lot in terms of the data. It's just combining them together and making something from it. And just wanted to quickly go in summary. Wanted to reiterate that data mapping is really useful. So for instance, in our biomass study, a lot of the first two data sources, we pretty much found through the data mapping process. So I want to reiterate that it is quite a useful process to identify data gaps and potential data sources for future studies. And also when it comes to novel approaches to estimating biomass and stock value and animal health losses, it can be applied in countries with existing animal registration and movement tracing systems. And finally, I suppose lessons learned include things like access, regardless of the time that it takes to get data sharing agreements. Providing access to such data can, as described in the previous slides, can be quite valuable. And when it comes to reusability, it should be something that we need to look into to answer different research questions as well. So it makes the process a lot quicker. And in terms of time being valuable, it's probably the most valuable resource and probably undervalued, but teamwork and collaboration can help with utilizing that time. So with that in mind, I actually want to thank my supervisors, Conor McAloon in UCD, Owen Ryan in the Department of Agriculture, and Jonathan Rushton in GBADs, also co-authors, and all of the groups that have been involved in the process so far. And I'm sure there'll be more groups, hopefully, out of this, if anybody wants to collaborate. But specific mentions to Centre for Veterinary Epidemiology and Risk Analysis, Animal Health Ireland, Irish Cattle Breeding Federation, GBADs, Teagasc, specifically, and thank you to DECIDE as well, and Work Package 4, and the Department of Agriculture for funding me. Thank you very much for listening, and any questions I'll try to answer in the chat, and yeah, thank you.
Thanks a lot, Emma-Jane. So as I mentioned in the chat, please feel free to put your questions there or ask them at the end of the 3 presentations. I realized that I forgot to introduce myself. My name is Gerdien van Schijk. I'm the coordinator of the DECIDE project. So that's why I'm chairing this session. Our next speaker of this afternoon is Camille Delavenne. She's a consultant at EpiMundi, formerly Ausvet in Lyon, France. And Camille is an epidemiologist trained as a veterinarian. And her project is on the reuse of non-scholarly data to improve the management of endemic contagious diseases, which is part of the Work Package 1 in the DECIDE project. And the idea is that she'll illustrate with this presentation moving from current practices, data management practices, to good examples of data reuse. Camille, the floor is yours. You're still muted, Camille.
Of course, I was going to forget something. Thank you, Gerdien and EJ, for the presentation and starting to build elements towards what we're going to talk today. So I'll present the work. So as Gerdien said, that we did in DECIDE for Work Package 1 with Céline Favergent. And so what, well, the first elements that started our work was the idea that today we all know that there's rapid growing volumes of data from diverse sources throughout the animal value chain, and so this so all across that, and this data can either be public or mainly private, and AJ kind of really showed examples of semi-public and private data sources, but most of those data sources actually have been created without a purpose of research. And for the rest of the presentation, I'm going to call those type of data as non-scholarly data, because it makes them a bit different to what to data that have been produced for that purpose. And the second element is that because there is that much data available, there's an increasing need to reuse this data for different purpose and tool, and so, and as EJ presented, it's actually not that easy to do. And my question that one of my first questions I'd like you all to think about while I'm going through this presentation is, have you ever actually gone through that process of trying to reuse non-scholarly data? And what are the major obstacles you've found? So some were presented by EJs, but you might have specific ones. And so based on that first observation, well, we started asking ourselves if non-scholarly data set produced by all those stakeholders, do they meet the requirement for data reuse and integration by us animal health scientists? And to start answering that question, well, we first try to identify available data sources for researchers. And for that, well, we had something pretty available at hand, which is the DECIDE project. So it's a H22 research project, if you didn't know. Its main goal is to improve the management of endemic contagious diseases and to produce decision support tools in order to achieve its goal. And the main plan on how to do that was to reuse data, and especially try to reuse private data. And so in that process of, it was planned to do an inventory of the data plan to be reused in the project. And so we could use that as our data study object. So to gain more information about all those data sets, we designed a survey. And the goal of this survey was to collect as much data description that we could. And when we say data description, it's an easy way to say that what we wanted to collect was metadata, information about those data sets. The main respondents for which we wanted to get information was mainly the stakeholders who were planning to share the data for reuse. However, we knew that we might not have access to them, so we at least wanted the researchers who were planning to reuse the data to fill in that survey so that we could collect as much information we could from those data sets. Once we had all this raw information, the question remains, how do we assess those data sets to answer our question? Can they be reused by researchers? And so, well, for us, fortunately, the idea of if a data set can be reused for research has actually already been answered by Wilkinson and I, who defined the FAIR guiding principle for scientific data management and stewardships. And basically, a data set can be reusable if it follows 4 main guiding principles. The first one being that the data set is findable, meaning that there is a way to identify that data set. The second element is that this data set needs to be accessible. There's a protocol, a way to understand how to get access to it. It's defined. And the data set should be interoperable. So meaning that it should we should have all the elements to be able to read it. And the fourth element is that the data set should be reusable. So we have all the context and rights to reuse it, so we understand the meaning of the data sets. And well, if I'm being completely transparent, all those elements are actually elements that need to be present when you're describing a data set. And so they correspond to the metadata. And what's interesting with the FAIR guiding principle is that not only the data has to be fair, but the metadata as well. The only issue with the FAIR guiding principle and our study is that it's designed for scholarly data sets. However, as I said, we're not exactly studying scholarly data sets, as our study subjects are private data sources or data sets that have not been produced for research purpose. So we can't exactly have the same, put the same standards and have the same, expect the same level of information from a completely different community to follow our standards and our research objectives. And so we therefore modified a tiny bit the FAIR assessment in order to focus mainly on principles related to good data management, excluding a few elements around machine actionability, persistence of information, and specificities are really linked to research community standards, so what we often call domain standards. And so, but I won't go into further details, but I can always go if you have more questions about it. And based on those 14 assessments, we actually went down to 12 assessments. And for each of the data sets, we gave a score. We came up with 12 criteria. And for each of the data sets, we gave a score from 0 to 1, assessing if they were fully met or not. And finally, we were able to describe our result. So first of all, in terms of the survey answers and the amount of information we received, we got information from 19 different respondents across 11 public-private organizations, and 63% of them had never applied the FAIR principle. Concerning those respondents, they gave us information about 30 data sets with very varied temporal, geographical scale, as well as it covered over 4 different species, and they had very different purpose, from production till surveillance to compliance with legislation, and they could come from 1 to up to multiple sources. However, there was some main characteristic across all those 30 data sets. They were mainly in tabular format for 25 of them, and they used vocabularies that were either based on glossaries, either self-defined and without a lot more details. And 14 of those data sets didn't have identified available metadata, or they had metadata that were partial, except in one case, and usually those were scattered across multiple documents. So once we had this information, we could start assessing the fair or modified fair compliance to our data sets and give it a score, either 0 if not the criteria wasn't met, 0.5 if it was partially met, or 1 if it was fully met. So answering for the first fair guiding principle, can we identify the data sets? Well, we had identified data sets for 16 of them. However, the metadata was only available for 4. Identified metadata was only available for 4 of them, and the link between the data and its metadata was fully described in only 2 of the data sets. Concerning if the data sets were accessible, so if there was a protocol describing how to gain access to the data sets, well, this protocol was accessible for 22 of the data sets. However, metadata access protocol was available in only 8. Concerning the interoperability of the data sets, can we read the data? Can we understand it? Well, we had documented data descriptions and data structures for 25 of the data set, and comprehensive vocabulary for 14 of the data set, meaning that a person outside who had no previous information about the data set could understand what's happening because there was additional information with it. However, once we start talking about the metadata, both for the documents describing the structure and the vocabulary used, this was available in only 1 of the data sets. For the reusability of the data set, so do we have the context of the data set and do we have the right to reuse it? Well, there was available additional information about the data set in 18 of the data sets, fully available. However, the data collection and quality processes were documented in only 10 of the data sets, and data and metadata was licensed only for 3 of them. So overall, what we're saying is that we have pretty low score, and especially whenever elements concerns metadata. And so what this really means and what this picture is really showing is that for any scientists who would like to reuse this data, it would require a lot of involvement from both the researcher and the stakeholder proposing the data. And if the time and the requirement have not been met, this also could potentially create errors and misunderstanding of what's the actual meaning behind those data sets. And so our first conclusion is that metadata are actually missing. And that's when I'm going to start again to ask you a question, is have you actually went through the process for your own data set to create metadata? Well, if you've ever tried, it's actually really not that easy, because you need a bit to be tech savvy and to understand what and how to use them. But not only that, today there's no specific guidelines oriented to animal scientists' need to support metadata creation. What I mean by that is there is no domain-specific standards to animal health. There are standards available that I've tried to put up, but there's no agreed on how to use them and which one to use and how. And so if that's a question you're interested in, I'm actually, we're going to go in further details at a workshop at the next SVPM conference in Berlin. So if you're ever interested, that could be somewhere where we could have more discussion, but we're still working further on that. So the other elements that our survey and our research was able to put front is that even if metadata creation is an issue, there's actually a real question about knowledge from the respondents. Our survey also reflects the knowledge that the respondents have of all those data management questions, and especially of metadata. And we've seen that the majority of our respondents had never applied the FAIR principles. And so there's a real question about also in the animal scientific community that is either planning to reuse data or either proposing data about data management elements, and a real question if we should improve and how to do so. And the last element, and this is really taking a step back, is once have you ever gone also in the process, because here we've asked for stakeholders to we asked other stakeholders to give us data so that we can reuse it. But have you ever done the other step, propose data to be reusable and render it to be reusable? And I'm asking this because, to our surprise, we found that a non-negligible part of the respondents didn't agree to make the metadata, so the data description, available to other project partner. And so the question remains why, and this needs to be further studies. But one of the potential reasons behind it is that the value of data reuse is actually not shared among the stakeholders we're talking about. And so there's potentially a real question about advocating for data reuse. And this is really important because Kassy is going to present a way to foster and help make data reuse. And so she's going to propose tools and processes to do so. But if we don't, as a community, agree on the value of data set, there's all the tools and processes she's proposing can't be sustainable because they won't be the elements and the power to keep it up. And so that's where I'm going to stop the presentation. And I really wanted to thank you all for listening and also to acknowledge everyone that participated in the study. So, of course, our funders and the respondents, but I would also highlight Céline Favergeron for work, Redine for her support, as well as SVA with Fernanda and Jenny, and Dima Ferhab from the Veterinary's Public Health Institute of Bern, who helped us a bit in the survey. And yeah, that's where I'm going to stop. Thank you very much. Okay. And this.
Thanks a lot, Camille. And it's an interesting question to the public, to the listeners of this, who created metadata, and I'm sure Kassy did it probably. She's going to be the next presenter. Kassy Raymond is a PhD candidate in computational sciences, University of Guelph in Canada. She was also the technical manager for the Global Burden of Animal Diseases Informatics team, and her research explores the operationalization of data governance principles to improve the quality, discoverability, and reusability of animal health and production data. So, Kassy, I'm sure you'll give us a nice example of what you can do with metadata.
Yeah, thanks so much. I struggle with the word that you stumbled onto. I won't even attempt it. Thanks so much to Emma-Jane and Camille for starting us off. I'm going to keep the ball rolling with my presentation entitled Streamlining the Discovery and Interoperability of Livestock Data and Classifications Using Metadata-Driven Graph Databases. And I just wanted to acknowledge that this work is a collective endeavor with my co-authors listed here as well from GBADs. So I just wanted to start by briefly considering the role of livestock data within the One Health framework. And this goes back to Emma-Jane's presentation. I think most of us in this virtual room are likely familiar with One Health, which considers the interconnectedness between environmental, human, and animal health. So why is livestock data so critical? Well, many One Health estimates or estimates that impact one or more of the pillars of health often require data on livestock. So these things include things such as understanding disease transmission, economic modeling, and food security, each of which also are important for tracking our progress towards the Sustainable Development Goals. So for GBADs, it's especially important to capture details like the type of livestock, their age and production system, breed and sex, to gain insights into population dynamics, biomass, for predicting disease outbreaks, managing resources, and informing policy. So in particular, within the GBADS framework, some of you may have already seen this image of the analytical framework. Livestock population is incredibly important. So you can see how it's used for biomass calculations within the animal health loss envelope, with which Emma-Jane mentioned earlier. So the livestock population data comes from intergovernmental sources such as FAOSTAT, the World Organization for Animal Health, or WOA, and Eurostat, and also from national statistics organizations, so places like Statistics Canada or the Ethiopia Central Statistics Agencies. And it's from these national statistics organizations that you're more likely to get more granular age, sex, production system categories, which are required for the estimates, like I mentioned in the last slide. So despite its importance, we have challenges with livestock data. And in general, the challenge is that the data can be really difficult to work with. One of the major reasons here, and as Emma Jane and Camille alluded to, is that there is no centralized or standardized repository for livestock data sets. So this means that you have to kind of sift through all these different data portals or do data mapping, and you don't really know how to find data, and none of the systems actually talk to each other. In other words, the data is not interoperable. So this means that there's no central access point to learn which data sets are available from the Ethiopia CSA, the UK, from Ireland, and FAOSTAT all at once, meaning that researchers spend a significant amount of time just trying to find data. And Emma Jane, Camille, and I talked about this at length in preparation for this webinar. And even once the data is found, there's often a lack of metadata. So determining whether the data is suitable for use and extracting the relevant information, so those domain-specific standards, is on another task for the researcher or data users. And so once they find the data, the metadata does not provide the level of detail needed. So it doesn't have that relevant information, such as the livestock classifications used to report the population data, because the data is often not even accompanied by metadata or provide the level of detail needed to understand what is actually in the data set. So things like age, sex, and production systems, which my friends at GBADs tell me is really important for designing and parameterizing population dynamic models, not in the metadata. With that, and those challenges in mind, my project set out to create a solution that addressed a few main goals. First, to understand the requirements for facilitating interoperability between different data systems that disseminate livestock population data. Second, to improve access and discovery of open livestock population data. This was my case study. And third, to start a library of livestock classifications used for reporting livestock population data from different organizations. And this was especially important because we wanted to start working towards a bottom-up vocabulary that can be used for domain-specific metadata. And I have this first objective grayed out because it's not the focus of the talk, but I'm happy to talk about it with anyone willing to talk about this with me because it's very niche. So the tool that we used to improve the access of the data was a labeled property graph or a graph database. And we used Neo4j as our graph database management system. So just briefly, Neo4j is a graph database management system that stores data in property graphs. So the main advantage of property graphs is that they allow us to store data in a connected format. So here in our example, we have nodes, properties, and relationships. The nodes represent people or cars, the properties, names, birth dates, brands, or models, while the relationships join together these nodes. So here we can see that Dan and Anne live together. They love each other. Anne is about 5 years older than Dan, and we see that Dan drives the Volvo that Anne owns. So it's a pretty good deal. So we use graph databases to store and manage metadata from different data sources. So what does this look like for data and metadata? In our example here, the orange nodes represent data sets, which would have information about the data sets as properties. So here the properties are the metadata, so the licensing information, the temporal coverage, the species, the name of the data set, the description, and the spatial coverage. But the interesting bit, at least to me, is that we've mapped out the columns and then the species represented in each of the columns in the data set, which are the purple nodes. So here in this example, we can see that FAOStat and Eurostat data sets are represented by the orange nodes and also the ice cream cone emojis, which just to make them pop a little bit more. And these two data sets share that they report data on horses, sheep, pigs, and goats. So by exposing the categories actually reported in the data, we can leverage these connections between the data sets and start to see the commonalities. And really what this allows us to do is design some interesting queries that allow us to traverse the graph, allowing us to make some interesting searches, which improves the findability of data. So let me show you what this looks like. In my drawing here, very neat and tidy, if I wanted to see what data was available for horses, the graph database allows us to traverse the graph and see that FAOStat and Eurostat both have data about horses. Similarly, you could do that with sheep, pigs, and goats. So using the system, this is what currently is supported for querying. So you can get a list of all species and species categories used for reporting data. This is an advantage because of the vocabulary point in the earlier slides too. You can get a list of all countries reporting data, and you can also return data sets that report a given species and country. So once you return data sets, you're provided metadata about the data, which look again like this. So you can have all the information about the data. Additionally, this is a little bit maybe cryptic for some members of the audience, but for data kind of nerds, you can get the JSON file, which provides you the size of the data set, the encoding format, and the date that it was last modified. This is referred to as technical metadata. So how can you query the graph? So the graph is currently hosted in the cloud and can be accessed via an application programming interface or API. You don't have to know anything really about APIs. Right now, you can access the data using R. So there's an example R script in our GitHub that provides some code in R Markdown to bring you through a few steps on how to query the graph. So for example, get a list of species available for query because you have to know what's available. So in this example, it just shows how to get that within R. And then from there, you can get all of these species categories. So this is basically your menu. What's available? What can I order from the database? What data sets are there? So from there, I can take one of those species categories. And I can search for data given a country and species using this command. So in this case, I'll look for the data sets reporting Canada that also have cattle. And then from there, you're getting some data sets that report cattle and have data for Canada. And then you can also get the content URL. So this is how you access the data set, and the other metadata is available as well. This is just a quick example. And then from there, you can download the data. And there's also other data available. So this it's from FAOStat, so it has all of the different countries, but this is just an example of how you can access data. So for what's next, our future directions is we have a lot of different data categories that are semantically similar. So of those few data sets that I just used to kind of create this prototype system, we have, I think there's like over 70, no, there's 54 species categories. And in this case, you'd have to specify cattle, non-dairy, and so forth to get the data sets associated. So we can group or cluster livestock categories to simplify the data menu to capture more data sets and optimize the querying. And that would be a really good idea, allowing users to more easily access the data. We should also add definitions of terms, publish this preliminary vocabulary, and disseminate it to stakeholders, such as our modelers who might benefit from these species categories. We'd also like to expand the repository of metadata and classifications just because there's only a few data sets in there currently. There's some limitations with the approach, including interoperability challenges. So because the data sources provide data in different formats and using different standards, you need custom data ingestion code for each data source. And this is time consuming, and you cannot completely automate the process of ingesting new data sources into the system because they're all formatted differently. We also need ongoing funding to continue hosting the graph database in the cloud, continuing to add more data sources, and also to just maintain the resources. So there is a GitHub account for those who know what this is and would be interested in using it. If you'd like to add a new data source to the graph database or suggest one, you can let us know on there. You can also contribute code if you've tidied data or metadata, and I've just provided the link for anyone who's interested. And with that, I'd like to thank my co-authors and also Emma Jane and Camille for working with me.
Thank you, Kassy. That was a really nice wrap-up of the previous presentations. I don't see any questions in the chat yet, but I was wondering the question of Camille. Can people raise their hands when they actually created metadata? Who in the public created metadata? You can use like the hands, raise your hands thing. Don't see any yet. Maybe people don't know how
do I do it?
It's in it's where you respond. Yeah, there's one. Yeah, so if you, there's some people in the chat responding that for other type of molecular epi work, you need metadata. So that I consider as well, working with metadata. Yeah, okay. So you're not the only one, Kassy.
Oh, there's a couple questions in the chat here. Do you want me to go?
Yep.
So
yep.
Joao asked about the comic I put in my last slide. This is kind of, I can share it. Is that the right? Okay, so this is a comic. And it's kind of it's a joke because often we hear that, oh, there's no standards, and then rather than reusing even elements of other standards, people just make new ones, and then you run into challenges with interoperability. So I'm not suggesting that there should be one global standard because I don't think that that's appropriate or that it would work. It's more so that rather than reinventing the wheel, you can reuse what's already available and then add additions to it as necessary. So in this case, it would be something like using the metadata elements like name, license, description, and so forth. But then in the livestock discipline, maybe we also need a metadata element called species so we can see which species are represented in a data set. We can add that onto a pre-existing standard to make sure that it's interoperable with other domain unspecific data sets and not create more challenges.
So there's a question for you from Celine Kassy about grouping the cattle terms. But I guess you could also use ontologies to do that, right? With graph database.
Yeah, that's a great question, actually. I didn't get to talk about it in this presentation, but within the informatics team on GBADs, there was a postdoc working on just this. So we have kind of like it's called Semantic Engine. It was a data portal called the Trusted Animal Information System, or portal rather, or TAIL, that's what we called it. And basically it worked by putting ontologies on top of the graph database to do exactly that, group terms and improve the discoverability of data that way. It's sort of difficult because in some cases, which I mentioned briefly actually, I don't think I mentioned it in this presentation. It was at ISB that I mentioned it. But the categories change over time. And so it's actually really nice to have the flexibility of the graph labeled property graph or graph database that manages those over time relationships, coupled with the ontology, which has strengths, but dealing with the temporal component of changing data sets is not one of them. But yeah, this is something that's sort of in the works, and it's a really good question.
Thank you, Kassy. There's a very nice question from Ben about creating metadata, and when you do that, you may help other people, and you get free riders that want to use your metadata but are not willing to create their own. I was just wondering, Emma Jane, did you create any metadata for the data that you used for your biomass?
Yes, still in the process of finishing it up. Pretty much in the same mindset of, you know, just even I suppose how an animal is classified kind of changes over time as well. So that the fun of that is probably a lot of time that goes into it. And I think when I've started the PhD, that whole process just finding the data and all and going through it and making the database graph and that side of things, it probably took a good 9 months. So it's not for the faint-hearted, I can tell you that much. So that's personal experience. I'm animal scientist as background. I'm not a data analyst, so I was learning as I was going as well. So I'm sure there's people in the audience that kind of just have the knack to to tech and to data and just can understand it a lot quicker than I could have. But yeah, that's my own personal experience anyway.
Does that match with what you found, Camille, when you were investigating the databases? Why was there no metadata in these data?
I think it varied because in some cases there was metadata, it just wasn't really identified as such by the respondents. In many cases, you didn't really have the structure. And I think one of the reasons is that when you do it in your organization, so being a private organization or something, it's not something that you might spend time on describing your own data set and putting all those protocols, because there's basically somebody who is aware of that. And so there is this kind of data management where you don't spend time on your data to make it really valuable and everything. And so we see that in many institutions. It's not something that's really proper to research and any other community. And so for me, there's multiple levels of why this is happening. And I'm thinking Ben's question about, what investment we can put to try and do it. And there's actually trials already to be done in most, for example, European projects. The data has to be fair in order to, we're asking people when they're publishing to make the data available and fair. And so there is trial to do that. I think one of the ways we can do it, and especially when we're having discussion with the private sector, is one of the output, even before you start, is actually you're going to spend time understanding the data sets. And so you can take some time to create those metadata and share them back with them. And so in that relationship as a stakeholder, but we've also seen that for some researchers, because they've done and they've put in that time, that make them the first and kind of the first research door for other researchers to have access. And so that gives them the opportunity to kind of have that first control for some research, and that has been described also. So there's really a lot of reasons why this is coming up. And so what I'm saying here has been described in other research communities. And so it's a good question to ask also of our own community, what's happening and at which level. And I think more research probably needs to go there. And but yeah, so I hope I answered that.
Yes, and there's some discussion now in the chat as well about the value of metadata and whether you should put it behind a paywall or something. But that would even decrease probably the possibilities to reuse data. Yeah.
There might also be, I've talked about funders, but there might be also, depending on the institution, some have realized and are putting more time. I think it was described that for archives that they propose data and metadata and as a process, and so giving researchers time for it, but it's not always the case. And so
But
this,
I find is often a problem if you're creating your own data in your project, right? You're doing clinical trials or something. That's when you can create metadata. But we are often doing projects in epidemiology or the burden of animal diseases, where we use data of others, right? Private institutes, farmers, and they are not interested in creating metadata. They're happy that we use their data if we are lucky, but they're not going to pay for us creating metadata. And I think that's one of the problems, right? That the owner of the data is not interested at all to create metadata. Is that a bit what you experience as well, Kassy?
I would say that there's been a couple of main challenges for like the production of metadata from research outputs. One of which is, people don't really know how to do it. There's not like a formal protocol on how to make metadata. And that causes it to take more time as well. So if you really want to do it, it's going to take all this time. I would also say too that for some projects, people are under tight deadlines and trying to get those outputs. And unless it specifically says within the things that you're supposed to deliver that metadata is a part of that, it's just not going to be a priority, even though it would benefit other people in the organization and, you know, be able to reuse each other's outputs. So I would just say that it's not seen sometimes as a priority, and that totally makes sense when there's other things that are priority to deliver in terms of like getting more funding and stuff like that. So it almost should, like in my biased metadata opinion, be part of someone's criteria. And I think that some journals are starting to kind of require this in an indirect way. But because there isn't very many guides on how to do it, everyone's doing these things slightly differently. So if you do want to make everything collectively findable in a data portal or repository, you also have to consider that you'll also probably have to hire or pay someone to do all this manual data stewardship in order to just ingest the data in the first or in the next place. And in that case, sometimes it's easier to actually just remake the metadata in the format that you need it. So, but at least if there's metadata there, you have something to go off of. But yeah, it's tricky. There's lots of different dynamics, I think, in play.
So that it would be one solution just to include an extra person in your project, right? You get a project and you make sure that there's a budget for somebody, a data scientist, that can make the metadata for you.
and I think there's two things to metadata, because there's like what's actually in the metadata, which is all the information we care about. And then there's the format of the metadata. And so usually the format can be kind of, if we want it to be very machine actionable, can be very kind of hard for anyone to understand and see, and how to retrieve that information when you haven't been trained to do it. And so because it doesn't appear in a way that's easy for anyone that doesn't have that IT background. And so it makes it much more difficult, and like collecting all this information is already one step, but then putting it in the format that would make it machine actionable is another one. And so sometimes, especially when we want to bring down to the discussion about, like, as a community, what do we want there to be? We just have to stop about the machine actionability and just ask ourselves that first question. The second element can be inputted. Doesn't mean that it's a two-level conversation, and maybe to bring people together, it's just first asking, like, what do we need? What information is important for us to be able to track and understand what the data set is about, and that we will need and we would like to do, like if we had a catalog of all the data sets, what information we would need to make the decision, is this data set useful for me or not?
Yeah, I think there's different levels to it. Like with interoperability, there's like it's called structural or syntactic interoperability. And then, well, technical is actually below that, structural and syntactic, and then semantic interoperability. And it's sort of this sort of thing. So yeah, the first thing that you have to do is know what you actually want in the metadata. And then if everyone's calling things, or like those elements, like calling everything that's a title instead of a name, this seems like a very minor detail, but from a technical standpoint, if you have to do all these mappings between each of the metadata elements for all of the different data sets, it's really, really taxing. And yeah, if there was an agreed upon for those metadata elements, I'm being careful because I don't believe that standards should be there for everything, because I think that they can be a little bit, I mean, in a conversation about standards, you need a lot of different voices to make it reflective of everyone. So that's difficult, but for the metadata element sets, so the title and name and that sort of thing, an agreed upon standard would be quite nice.
Ben has another nice creative solution in the chat. So do you want to respond to that? Would that be an option?
I'm just reading it.
It's could we have a metric whereby reuse of someone's data, metadata is also tracked. So when you're publishing and when you cite papers.
I don't really know how much it's actually used, but so there's a few portals where you can put your data and it's linked to that. And so you can put your data after you research, and it's a lot of the published article like you to do that. So it's things like Zenodo or things like that. And so I guess those and the reuse of those data set could be something that's tracked because everything is already pretty much in place. But I don't know if it's actually done really now. I haven't asked myself the question, so I haven't looked especially for it, but that would be where I would find the information. Yeah. Kassy, I don't know if you... One way that some, because the idea of fair research and at least reusability inside of research is actually going on, and the conversation is going on in many other fields. And so there's been publishers that also have started agreeing for just the publishing of a data set and its description, and that being a publication by its own to render it reusable by others. And so that also is a way to foster this practice inside the research community. It's just, the question remains, yeah, I guess, with external stakeholders and that first step when you get data to be reused and how you do it. But I guess the more researchers already know how to do it themselves inside the research framework, the easier it will be also to do that conversation with others.
Yeah, I think so. Within the FAIR principles, and just in terms of data management in general, it's really great to have data sets and metadata with unique identifiers. So that means that that doesn't change and is stable on the web over time. So it's basically like the DOI for an article, but it's for your data set. And in that case, if there's a unique identifier for a data set, you could cite it. And within the metadata that it would then link to, it would have things like author information and who created the data set, and any other relevant information that the metadata creator would have added in there. So in that case, it's not necessarily like ResearchGate or if you see how many people cited your paper, but I'm sure it would be possible if most metadata and data were accompanied with that unique identifier.
Okay, thanks. I see that it's 4 o'clock. So I guess with this last remark and interesting solution, Kassy, it's something I have to think of, I think, for journals. I would like to thank all the speakers. I thought you did a wonderful job in showing all the elements of metadata and what you can do with them and what difficulties you run into. You did well in answering the questions. I want to thank everybody listening for their questions and their attention. And I hope to see you again in another webinar. We will have one again probably in March or April of this year. We'll keep you posted on that. Thanks, everybody, and see you around.
Thank you.